Human beings evolved on Earth, and so we need conditions like Earth's to survive. Unfortunately, Earth is also a unique planet in our solar system, and the only one that's habitable for us. Arguably, the closest thing we have to Earth is Mars, but currently we would die within seconds on its surface without protection. If we ever want to expand farther into the stars then, to Mars or to anywhere else, we have two options: to build habitats with self-contained ecosystems, or to terraform moons and planets for humans. We're already trying to build a base on the moon, but living in an artificial habitat brings potential dangers. A base has to be crafted to withstand a harsh environment, and failure of its life support systems could mean tragedy. With this in mind, the long-term goal would be terraforming, the act of transforming a hostile environment into one that's habitable for humans. And it's a great idea, but a very hard thing to do. Some of the challenges with Mars in particular are its low gravity, unbreathable atmosphere, lack of food, toxic soil, temperature, and more. These are all problems that will eventually need to be addressed. One of the most important aspects of living on another planet sustainably is using the resources on the planet itself, a process called in situ resource utilization, or ISRU. Even if we manage to set up a base on the moon, for instance, astronauts can't only depend on supplies to arrive from Earth. They'll need to be able to produce their own air, food, water, etc. The same will be true on Mars. The idea of terraforming is to create an environment where we can walk around in the open air and harvest our own supplies without depending on supplies brought in. NASA and other agencies are going to try this on the moon by harvesting fuel from deposits of water ice. Mars is another problem altogether, though. Even at its closest approach, it's still 200 times farther from Earth than the moon is. When it comes to making a planet livable, oxygen is maybe the most important factor for survival, because without it, we quickly suffocate. And as it turns out, NASA has already been adding oxygen to Mars. On February 18, 2021, NASA landed a rover on Mars called Perseverance. Its job was to test the Martian soil and rocks for signs of ancient life while collecting samples. But stowed away among its equipment was a machine that scientists called MOXIE. MOXIE stands for Mars Oxygen ISRU Experiment. And in April 2021, NASA announced that Perseverance had been successful in using this equipment to, for the first time, convert a tiny amount of the planet's carbon dioxide-rich atmosphere into oxygen. Scientists then ran the machine 7 different times throughout 2021. And not only did MOXIE succeed in creating oxygen, it managed to do so in a variety of harsh conditions. It produced oxygen while running in different seasons, temperatures, pressures, and times of day, showcasing its feasibility and dependability in different types of weather. Altogether, it was able to output an average of 6 grams of oxygen per hour, or the same amount that a small tree would create on Earth. Producing oxygen on Mars will be key for creating fuel so that astronauts can fly back if they need to. Using an oxygen-methane-based propulsion system, for example, people on Mars would need about 31 tons of oxygen in order to achieve liftoff. Oxygen would normally be very hard to find on Mars without mining for water. But since the Martian atmosphere consists of 96% carbon dioxide, we can actually, thanks to MOXIE, turn that into oxygen. MOXIE works first by collecting air from the Martian atmosphere through a filter to ensure that no dust gets into the machine. It then compresses this air into a higher pressure and heats it up to 800 degrees Celsius, or 1,472 degrees Fahrenheit. Next, the air enters a solid oxide electrolysis instrument, which works by using a nickel-based cathode to split the gas up into its constituent parts of oxygen and carbon monoxide. Oxygen ions are then passed through the anode, where they recombine into O2 and are released into the atmosphere after testing the quality. Although the machine is small and only able to produce a small amount of oxygen, this was only the test run. The first model of MOXIE was about the size of a car battery, but future generations will be 100 times larger. Researchers are already working on upscaling MOXIE to something the size of a freezer, which could manage to produce several hundred trees worth of oxygen before long. This could raise production from 6 grams per hour to 3 kilograms or more. In general, these generators are inspired by trees on Earth and aim to mimic their photosynthesis functionality of transforming carbon dioxide into oxygen. Eventually, in the future, Mars could have an entire forest of electronic trees then that produce oxygen, slowly terraforming the planet while also providing fuel. And again, the very first tree of this forest is already up there, planted and working. The success of this mission can't be understated, and it's the very first time in history that humans have attempted to use another planet's resources instead of depending on Earth. As Moxie Deputy Principal Investigator Jeffrey Hoffman said, quote, "This is the first demonstration of actually using resources on the surface of another planetary body and transforming them chemically into something that would be useful for a human mission," end quote. Of course, Moxie's successes thus far don't mean that it will be easy going forward. Some of the main problems for upscaling energy production are both efficiency and fuel. Moxie currently uses 300 watts of energy to produce around 8 grams of oxygen, which isn't a great ratio. It's only about 10% efficient, and will need to be closer to 90% efficient to be viable. To run a bigger machine reliably, scientists will likely need to use nuclear power. But the good news is that NASA already uses nuclear power for their Perseverance rover. Perseverance runs off the heat produced by the radioactive decay of plutonium to make fuel. This system is known as the Multi-Mission Radioisotope Thermoelectric Generator. Ideally, in the future, scientists will need to create a nuclear generator that produces 10 kilowatts of energy, and this is currently being specifically investigated by NASA. Although the only model to ever produce oxygen on Mars is the Moxie machine, the same company that created it has already tested a follow-up that is 100 times bigger on Earth. So watch this space for the relocation of that. Until then, NASA has seemingly solved the problem of creating oxygen on Mars, equipping the red planet with one of the most important ingredients for human life. Small amounts have already been released into the planet. Now we need only find the answers for producing food, water, and shelter as well, if we ever seriously want to live there. Fortunately, there have been some advancements in these areas as well, such as in 2022, when NASA announced that they had successfully grown plants in lunar soil, giving hope for doing the same on Mars. Of course, there's plenty more work to do, but the first steps have been made towards reshaping Mars into a planet that humanity can one day walk around on. And that's how NASA is already terraforming Mars